ready for number 23. 23A says draw an accurate graph of the speed versus time for the train in problem 22. So we look back at problem 22. A train initially stationary has a constant acceleration of 0.5 meters per second squared. So let's look at the information that we have and then create that graph. We have that acceleration is equal to 0.5 meters per second squared. From that, we're going to create a table. They've asked us to graph speed versus time. So we're going to create a table that is speed versus time. We're going to pick some arbitrary points that will make it easy for calculations. So we'll go 5 seconds, 10 seconds, 15 seconds, and 20 seconds. Then we simply use the equation that velocity or speed is equal to acceleration times time. So we're just simply going to take 0.5 times each one of our times. 0.5 times 5 gives us 2.5 meters per second. 10 times 0.5 gives us 5 meters per second. 15 gives us 7.5 meters per second. And 20 gives us 10 meters per second. Now that we have those numbers established, we'll create our graph. So we have speed versus time. I've given the same seconds or the same speeds, set those up on the axis, and then I've got the time down here on the horizontal. Okay, so from our table, 0.5 gave us 2.5, 10 gave us 5, 15 gave us 17.5, and 20 gave us 10. And so then we can see that the best fit line simply extends as a straight line. This tells us that it is constant motion. Part B. Part B says to draw an accurate graph of the distance versus time for the train. Now we're looking for the distance. So given the same information that we had, that acceleration is 0.5 meters per second squared, now we're going to calculate distance. And we're going to use the equation that distance is equal to 1/2 AT squared. AT squared. Again, we're going to pick some arbitrary points. We're going to create our table. We've got distance and time. We're going to start out with 1 second, 2 seconds, 3 seconds, and finish up with 4 seconds. So 1/2 AT squared. 1 second squared gives us 1, times 0.5 gives us 1/2, times another half gives us 0.25 meters. Plugging in 2. 2 squared is 4, times 0.5 is 2, times 1/2 again is 1 meter. 3 seconds, we have 9, and times 0.5 gives us 4.5, times a half again gives us 2.25 meters. And then 4 seconds. 4 squared is 16, times 0.5 is 8, times half again gives us 4 meters. Set up our graph almost exactly the same. Obviously switching in distance. And then plotting our points. At 1 second we had 2.25 meters. At 2 seconds we had 1 meter. At 3 seconds, we had 2.25, and at 4 seconds, we had 4 meters. This time, our graph is a curve showing that there is a change.